So, when we are dividing radicals, sometimes you get lucky. Say I wanted to do something like the square root of 10 divided by the square root of 5. If they're both under a square root, you get to divide it like it's a normal fraction. So in other words, you can rewrite this as one big square root of 10 divided by 5. As long as they're both under a root, I can reduce them with each other. So 10 divided by 5 is just 2. So this just comes out to be the square root of 2, and I'm done. So sometimes it can be super easy. If I had something like this, say I had, how about 2 root 6 divided by 10? Okay? You can't divide, I can't reduce the 6 and the 10 with each other because the 6 is in a square root and the 10's not. However, the 2 and the 10 are both not in a square root. Do you see that? So I can reduce them with each other, right? 2/10 would just be 1/5. So I just get square root of 6 over 5. That's fine. So the rule that we've been dealing with the whole time basically still just applies to division. If they're both in the root, you can do whatever you need to do with them. If they're both out of the root, you can do whatever you need to do with them. But if one's in, one's out, they can't really do anything with each other.
Would it stay like that as a fraction, or would you
Yep.
try to do a 5 or 6?
No, because 5's in the denominator, so it would just stay like that. Yep. However, if I had a square root in the denominator, that's a problem. So someone at some point decided that you're not allowed to have square roots in the denominator. Just like someone at some point decided you have to start a sentence with a capital letter. I don't know why, it's just convention now, right? So we always just start. So it's the same thing. So if we have a square root in the denominator, we have to do what's called rationalizing the denominator. So I basically have to get a square root out of the denominator. I think it's a pointless exercise, so why are we doing it? Basically, you have to. If you're going to take the SATs or the MCAS or whatever, all your multiple choice questions aren't going to have radicals in the denominator, so you need to be able to convert. Even though mathematically it's going to be the exact same number.
How would you do that if you say that there's a radical in the denominator?
Yes.
You can't divide it by 9.
Okay, let's do it. So if I had this same fraction, but let's just flip it over. Let's say I had 10 over 2 root 6. I can still reduce the 10 and the 2, that's fine. So that's a 5, that's now a 1. So now I'm here, I have 5 root 6. And I'm telling you, you're not allowed to leave a square root in the denominator anymore. Yeah, you have a thought? Yeah, yes, sort of. So I'm not, that is my answer, right? I can't change its answer. Like up here, well, all right. Let's say that the answer to some problem was 7, right? Okay, it's 7. I can't just all of a sudden turn it into 14. But what I could do is I could turn 7, I could multiply it by 1, right? And then isn't it still 7? Right? I know, you're thinking, well, why would you bother? I would bother here. I can multiply this thing by the square root of 6 over the square root of 6. Isn't that just 1? Square root of 6 over square root of 6 is just 1, right? If I had the same exact thing on top and bottom of a fraction, it's just 1. But watch what happens when I actually do that. If I multiply across the top, I have 5 root 6. What do you get on the bottom? What's root 6 times root 6?
36.
Square root of 36, which is just 6. So if I took out my calculator, which I will in a second, and I did this, which was my original answer, if I do 5 divided by the square root of 6, it's going to spit out some crazy decimal. If I do this, 5 times the square root of 6 divided by 6, I will get the same exact decimal. So they are really the same number, it's just written in the form that's allowed, if you will. So 5 divided by root 6, let me show you. 5 divided by the square root of 6 is that crazy number. Okay? So I should get the same exact thing when I do 5 times the square root of 6. And then I need to divide by 6. Ta-da! So you see, they are the exact same number. Like, not even like rounded differently. Exactly the same. Because all I've done was take the number and multiply by 1. If you take a number and multiply by 1, it's still that same number. It's basically changing 4 quarters into a dollar, or vice versa. Right? It's still the same amount of money. It's just in the form that I can use. Okay? So, let's try something like, I'm just looking at your sheet here. Number 7 has square root of 5 over square root of 3. Now, if I could have reduced 5 over 3, I would have, because they're both in the house. But I can't. But I can't leave my answer like this because it has a square root in the denominator. So how am I going to fix it? Multiply by what? Square root of 3 over square root of 3. And that should fix it for me. I can have square roots in the numerator all day long. It's just not allowed in the denominator. So what's my new numerator?
Square root of 15 over 3.
Yep. Square root of 3 times square root of 3 is square root of 9, which is just 3. Can I simplify the 15 and the 3? No, because the 15's in a root and the 3's not. They'd either both have to be in or both out. But I can't have 1 and 1. Take a look at something like number, let's just do 8 real quick. You have the square root of 2 over 2 square root 3. So here's a very common misconception, that you have to multiply by 2 root 3 on top and 2 root 3 on the bottom. You actually don't have to. Because the 2 is not the problem. The 2 is fine. It's the square root of 3 that I can't have. So, my easiest thing to do is just multiply by root 3 over root 3. If you multiply by 2 root 3 over 2 root 3, you're not wrong. You just have a bigger fraction to reduce. So you're making more work for yourself.
Wait, multiply by what? You make more?
People are going to multiply by 2 root 3 over 2 root 3. Because that's the denominator. But I'm telling you, you don't need that 2 there. Right? Because 2 in the denominator is no big deal. I just have to get rid of the square root of 3. So what's my new numerator?
6.
Square root of 6.
Over 6.
Yeah, over 6, right? Because square root of 3 times square root of 3 is square root of 9, which is just 3. 2 times 3 gets me 9. I mean 6. Oh gosh. Just kidding around. Six. And then can I reduce those?
No.
No, because one's in, one's out. Is this okay?
Yeah.
Try something like number, oh boy, look at these variable ones.
Yeah, you should teach us how to do variable.
Okay, let's do 9 together then. Okay, you're going to work smarter, not harder. You can reduce a whole bunch of things first. See how that's in the root and that's in the root? So anything in here that can reduce with each other, I can do that right off the bat. So I can't reduce 3 over 5. Okay, too bad, so sad. So let me make a new fraction. So up top, I'm still going to have a 3. That 4 is just hanging out in front. And downstairs, I'm still going to have a 5. Look at the x's, though. If I have x squared on top and x on the bottom, yes, that just becomes x to the first on top. Right, y to the third just cancel with each other. So this is a lot better to deal with. So I'm not done because I still have a square root in my denominator. But all I have to do to get rid of it is to multiply by square root of 5 over square root of 5. And I will be done. And what's that denominator going to be?
20.
Yes. Because that gets me 5 times 4. So here's my final answer.
F.
Right. Oh, sorry. Thanks. And I can't reduce that any further because the 15's in the house and the 20's not. Let's try one more with the radicals. How about square root of number 10 I'm going to do. Okay, here's number 10. Do what you think you can. Okay, we got it. So I'm going to start off, well, that 3 is just going to hang out in front, right? And then I realize, hey, I can reduce 15 and 10. That would just be 3 over 2, right? So let's put that in, 3 over 2. The x's are just going to cancel with each other. X over x, they're just gone. And then if I had y over y to the 3rd, what would that leave me with? Y squared on the denominator. So now I'm here, but I realize I can do something else before I get rid of that square root in the denominator. Does everybody see what I can do? Yeah, I know what the square root of y squared is. It's just y. So my denominator, let's pull that y out, and then I would just have that. You see how I did that? You could do it at the end, but it's going to make my life a lot easier now to just get rid of it here. So now all I have to multiply by is square root of 2 over square root of 2. And I should be okay. So let's see if I can fit this. So my new numerator is now square root of 6. And my denominator, square root of 2 times square root of 2 is square root of 4, which is just 2. 2 times 3 is 6y. Oh, hey. Yeah, I was actually coming to find you. In Algebra 1, Part 2, CPA, how much cube root stuff do you do? Do you remember? Do you do like operations with cube roots, and like if you have a cube root in the denominator, do you?
Cube roots have numbers.
Just numbers. Okay. I did variables, but I couldn't remember if you had, and we did like basic operations, but I didn't do like, if you have a cube root.
Do operations.
Oh, I do. All right, I just want to make sure that I'm done with cube roots with them.
Yeah. Okay. Great. She said I've got my first password. Okay. I'll see you.
That kid, remember yesterday that I had to leave A block and go in there? Because that kid?
Oh yeah, my kid.
Oh, yeah, I didn't know you knew it was your kid. I didn't realize that you had him.
Wait, what about the kid in senior?
Yeah.
Oh, this?
Yeah. Well, I was telling Gretchen, and she was like, because I told her that I was like, oh, I came in here waiting for you, but then I had to leave.
Yeah, I have to.
Yeah, and then she's like, oh, yeah, Jen's got him. And I was like, oh, she does? Oh, my God. All right. Bye.
So
Okay.
So we don't have to do this, 'cause she said she does teach it.
Oh, we're not going to do any more with cube roots. Because there's like, when you have a cube root in the denominator, it's a whole different thing. So we won't rationalize denominators with cube roots. You'll do that in algebra 2.
Miss Xavier, what happened to the kid?
Guess you'll never know.
Come on.
Oh, man.
Come on.
Actually, not a very good story at all.
Probably
All right.
figured out his task.
Oh, yeah. So, did you guys get the same final answer? Okay.
No, I didn't get it. I did something wrong.
You might not just have simplified all the way.
Nah, I multiplied it.
Oh, okay.
Well, no. Yeah, I didn't simplify. That's what you said. The 15 and the 10, I didn't do that.
Oh,
I
yeah.
knew you could do that.
Yes, as long as they're both in the root. You should do it to make your life much easier.
Yeah, I didn't do that. And then that's what got me all messed up.
So there is a little bit left of dividing that we need to do, but we don't have time to do it today. So let me tell you what I want you to do for homework. On the multiplying page, can you do all the multiples of 3? I think we may have done many of them. So if there's any ones that we've done, you can just skip those. So both sides, on the multiplication side, multiples of 3. Both sides. And then on the division page, just finish 1 through 10. One through 10 only. So again, we've done a bunch of them, so there shouldn't be too many left. Everybody's got that?